Hey, math moment makers. As you probably know, for those who have been listening to the podcast, I've been in a role where I
Mm,
get the awesome opportunity to jump into all kinds of different classrooms across from K through 12. And I've got to say, though, the one thing that I still see a whole lot of is our approach to teaching math classes still looking pretty common to how I remember and how I taught
mhm.
for quite a few years.
Yeah, and I'm really excited to chat in this particular episode because I think what we also see is a ton of people asking. It might be on social media, it might be in our private Facebook group, it might be in the academy, but people are saying like they'll ask like how do I like take lesson X, or how do I grab topic Y and teach it so that my students are engaged, or it's like a better lesson than what I've done. It's always like, how do I take that and change it? And then that's what we're going to talk about here in this episode. We're going to unpack the real flipped classroom and how to
Ooh.
transform a typical lesson into an engaging problem-based math lesson. We're going to share how to slowly emerge shortcuts instead of giving them up front like I did for so long. And finally, we're going to chat about what to do if students aren't engaging with those problem-based lessons we've just transformed.
All right, math moment makers. I'm excited to dive into this one. I hope you're just as excited as we are. So let's dive into this jam-packed episode where we're going to unpack how we can problem-based math lessonize our typical routine math lesson. Here we go. Welcome to the Making Math Moments That Matter podcast. I'm Kyle Pierce.
And I'm John Orr, and we are from makemathmoments.com, and we are two math teachers who together
with you, the community of math moment makers worldwide who want to build and deliver math lessons that spark curiosity,
fuel sense making,
and ignite those teacher moves. Friends, as we mentioned, one of the most challenging pieces that I find is when I'm working with educators who are super eager, like super keen on trying to, make their lessons more engaging, make them more problem-based so that it's not them doing all the talking. One of the hardest pieces is like, where do we start? Like, where do we begin? And that is exactly what we're going to be doing here today, right, John?
Yeah, we definitely are. And we were going to unpack some important aspects of this idea of this like real flip classroom. And we're not talking now, let's just get this out of the way, right, Kyle? Like when some people hear flip classroom, they're immediately thinking to like, what was it, like 6 years ago? It was very popular. It was like, let's change our lesson format so that we're teaching through video, and then kids can learn the lesson at home, come in, and then we can do the engaging problem or the application problem. I can be there to help them on the tough homework. There was in math class a number of years ago, if I'm ringing some bells for you folks, is that was called the flipped classroom. We're not talking about that. We're going to unpack what we call the real flip classroom, but we're gonna kind of talk about like tomorrow. Like, think about this. We're gonna you want to be in a place where you're like, tomorrow I'm going to teach this topic. And for me, for a long time, it was like, let me pull that one out of the binder I did from a year ago. And usually for me, it was, I'm going to show a couple of examples, and then I'm going to have them do a couple of examples on their own. And then it's like, now it's practice time, and I walk around and help that whole time. But we're going to change that here today, and we want to show you how to do that. But we want to do that so that it's definitely changeable for tomorrow's lesson. That's an important aspect. So a lot of times it's like, people are like, or maybe you've listened to lots of episodes before. The first 4 episodes, we talk about problem-based lessons and how to modify things. And a lot of the things we talk about there take time to develop. But in this episode, we want to give you some actionable items that if you're starting to change your math lessons, what can you do tomorrow so that has a profound impact on your pathway forward?
Yeah. And, kind of going back to that whole flip classroom thing, it was like, the idea was basically like, take your regular lesson and we're still going to do it in the same order. It's just that we're going to bump it a little bit earlier, and we're going to get like students to like do the lesson at home from this video. And we don't want to do that. We actually want to take like the elements of these lessons. And, let's just be clear. Like when John and I talk about what we consider to be like our, more traditional, or what we remember, early in our careers teaching, or the way we were taught, is that, as John mentioned, like we would pre-teach everything students need to know up front, right? So we would, introduce the concept. If the concept is slope of a line, we'd have a title on the board. We might even define it. Like the first thing we do is like define like, what is the slope? Well, I can't teach you a lesson about slope unless I tell you exactly what slope is. We get that all down on the board. And then, students are going like, okay, I'm not really sure what you mean. Don't worry about it. I'm going to give you some examples so that you can see what slope of a line is all about. So we're not saying not to use that lesson. What we're saying is like, we're actually going to try to just rearrange it a little bit. And we're going to encourage you to, instead of sort of pre-teaching these ideas, we're going to think about like what part of our lesson, and I would argue it's probably somewhere in those examples, or maybe even like some of those textbook problems that you might assign later. Like there's a gem in there somewhere that you might be able to like grab, and you can use that as your opener for your lesson. And it's sort of like, it's sort of this opportunity for you to come to this lesson and almost like create a reason why we're going to talk about this concept, instead of me sort of like, it's almost like, saying like, just hang on, like, telling the kids like, just stick with me. I promise it's all going to make sense in the end. Here, it's like we can take something, we can almost give students a bit of this productive struggle up front in order to, Dan Meyer would call it, like almost like create a headache in the math classroom a little bit, like create the need for more efficiency, for like this new concept that we're hoping to bring to the forefront. So that's really what we want to do today. And again, the one piece we really want to drive home is we don't want this to be super, strenuous on you, a huge amount of planning. We want you to literally take that math lesson that you had and kind of look and think about it and go, what part of this can I bring to the forefront first? Right, John?
Yeah. And I think that's a really good point, because if we can bring that to the front, it's not something that you're going to have to overhaul that whole lesson. And that's an important aspect, because we've talked about that here on this podcast before, in the sense that you might want to try a problem-based lesson on one day, but it's almost impossible if you're starting out and trying to do that every single day. So it might be like, I've got this plan to do this great lesson that's engaging. It's going to use these aspects that I heard on a particular episode of the podcast, or I saw at a conference. But in the meantime, it takes a lot of planning to get there. In the meantime, how do I change these lessons so that it's not going to like take me all night to plan? And I think that's what we want to do here. It's like, we're going to take the lesson you already had from the previous year, or maybe it can be it's something that you planned this week, but it doesn't take too long. But like what Kyle said, it's like, we're going to take some elements and move them to the front. And then usually, and what we would do at the front, we're going to move to the back. And that's what we call the flipped classroom. We're going to bring in a problem or two, or a series of problems, and have our kids actually think their way through that problem. And then through what they do, you might also bring up some examples later, but also create the note later in the lesson, not say right at the beginning.
I love it. So let's dive in here and let's talk about this and really try to help people sort of envision what this might look like. So we've already talked a little bit about the order. What we're hoping that will happen from this by doing this little by little, each day, it's almost like setting yourself a bit of a goal. In our online workshop, there's one of our lessons where we talk about not breaking the chain. And I think this is a great place to set yourself a goal. It's like a small enough goal where it's like, if each and every day, I don't want to throw out my binder or throw out all the resources I've used in the past. I just want to think about tomorrow's lesson. What can I do in order to bring the idea out at the beginning and push some of the teaching, which John and I would like to call like the consolidation process, right? The consolidation process from like the 3-part math lesson. Some of you might be familiar with the John Vanderwall 3-part math lesson. We want to do the thinking up front, and then we want to do the teaching, tying of loose ends a little later by simply doing this thinking each and every day before you plan that next lesson. You can get yourself into this habit where things will start to come to you, and those lessons will over time, they're going to get better and better. It might not be the best lesson the first time you try this. That's not really what our goal is here today. Our goal is to get into the habit of trying to bring this to the forefront so that we can get students thinking. And then also sort of like once they've done that thinking, like think of how much easier it is to try to teach a concept like the slope of a line when students have been playing with a problem and they've all come to answers. And some students have used different elements of, say, the slope, or, some students have used a table and noticed the pattern to be able to like take this student thinking and then be able to like notice and name that slope right there. Like this, we're going to call it slope instead of us doing all of that pre-teaching and talking about slope. And here's how you calculate it. And here's where you might find it, all of these things. And then now it's like, now let's go actually find where slope is in all these problems. It's like, we're going to bring it together and we're going to be able to kind of put a nice bow on things and go like, did you see how John did that over there in the table? Like, wow, that's interesting. Did you see how someone over here used a graph? Wow, look at that. Did you see how this student just like used number sense? Like they were just using, multiplication, addition, division, all of this stuff over here. I'm wondering, like, what do you see common about these ideas here? What do you see common here? And they'll notice this thing, this rate, and we can name it the rate of change or the slope of the line and start to kind of build this, we'll call it like this big foundation around this idea instead of, like I say, doing all this pre-teaching up front.
Right. And I think that it's important to note here about the way that Kyle has just outlined this example about using slope in one sense, that we didn't teach the students up front about what was going to happen. And we gave them a problem to solve, knowing that we have not yet introduced the idea of slope. So Kyle, I think people out there are kind of wondering, like, okay, well, I normally would start my lesson and teach them about slope, but now I have to like put a problem here to bring out slope. And that's an important aspect because that's tough to do sometimes. And that's what we want to kind of focus on here for the next minute. And the second thing is that when Kyle, when we're referencing that people, where you're observing kids do different things, like pulling from this, pulling from that, I think what I didn't do that initially, Kyle, when I first started changing my lessons. I was like, what we're talking about here is like, I changed when we did the thinking up front, but I wasn't at a place when we first started doing that to be like, I'm going to reference that person's thinking here, or I'm going to call upon them to share. My first instance was they all did the work around the room, or maybe they did it on their desks and I watched and I could see, but I mentally referenced what different strategies students were doing on those problems. But I wasn't at a place in my comfort level of teaching to call on that or point it out to the kids or have them explain. What I did instead was when I wanted to do the note, right? Like they did this problem, and that problem may have emerged a shortcut that we were aiming for, right? Maybe the topic was like terms, or maybe we felt like we got to a point where we needed some instruction to move forward, right? We've created a need for the next step, and you get to step in and go, okay, this is a good moment for us to talk about, concept X. And so what I would have done back then would have said, okay, I step in, or I'm ready to talk about the shortcut. And then I would have gone through an example, and then I could have said, you know what? So-and-so did use this over here on their solution. And I kind of just walked through it as a full example. Like I used some of their numbers in my examples. And that's the nice thing about having your kids do that problem first. And if you take it up and walk through it and bring out the elements of like terms, or in your example, slope, you get to reference the numbers, and they get to see the numbers they used in your solution as well. And I remember that I'm in a different place now. I'm more like what you said, is we'll reference different strategies and we'll pull it all together in a consolidation. But before I was ready for that, I mimicked this, I took up the solution and then made sure that we pointed out different values that they saw.
Love it. Love it. And, you know, I what I'm hearing you say is like, you're giving people permission to kind of start where they
Right.
are, and not, you know, sort of look at this as like overwhelm and go, wait a second, you said we were just going to like take one part of my lesson and put it over here.
Exactly.
You're saying that, you know what, maybe that's exactly what it will look like. And maybe there's this goal of moving towards, you know, using student generated solutions, but maybe that's just not where you're at yet, right? And that's okay too. So it's like taking that step. I'm really happy, you know, you kind of highlighted that, because again, we want this to be that first step for some people, or that next step. So for example, if, you know, if you're already doing that, and maybe it's time for you to take the next step to say, hey, I do want to consolidate utilizing student generated solutions. But maybe if you're just starting this process, maybe it's one step at a time. I love that idea. So, you know, I'm thinking about this and I'm going, okay, I could begin by simply grabbing one of these like example problems that I might use, or maybe it's a problem out of the textbook that I might have normally assigned and maybe waited to assign, because we always think like word problems are, you know, students can't do those. They have to be able to do all the naked problems first, right? All the ones that are just, you know, calculating and following the procedure. But really what we can do is actually like grab one of those, bring them to the front, and then we have to sort of ask ourselves a question. And the question is like, what are we hoping students will walk away with, right? And that's kind of a scary question. I'll be honest and say, like, some people worry that it's like, well, what if I pick the wrong thing? And, you know, the reality is that that's going to shape over time, but you have to at least start by thinking about like, what is the intentionality of why we're doing today's lesson? Like, why is this mathematics being taught in the curriculum? How does it help us? You know, something John's been using a lot is this idea of a cheat sheet. He's like, what is it the cheat sheet for, right? Like if we're in math class, you're basically helping students to essentially stumble upon something that's going to be beneficial for something that they might encounter. So the question then becomes is like, okay, if I can identify what that thing is, that can help me select that problem that I might use at the beginning of the lesson. And that to me is one of those big key pieces here. And we want to think about like what sort of understanding or skill are we hoping that they're going to learn throughout today's lesson, so that if they were to like see a problem like the one they'll solve at the beginning, like let's be honest, if they solve that first problem, they're most likely not going to be using the new concept that you're introducing that day, right? Otherwise, we wouldn't be teaching it. So you're going to see them using inefficient strategies. And this is like, you know, where you have this freedom to just let students bring what they have. And we've talked about this a billion times before. It's like in this mode, in this phase is where you get to learn a lot about what students are bringing to the table, right? Like, are they thinking additively? Are, you know, so they're skip counting. They're not multiplying. They're just adding. Okay, that's really useful information for me to know. And if the thing that we're going to be exploring today involves multiplicative thinking, you know, I might need to like take that into account when, you know, when we actually do that portion of the lesson, like how are we going to bridge that gap? So there's so much that we can learn and glean when we offer students this opportunity. But then also, I think it really helps students kind of get their heads in the right space in order to go down that path to this new learning, right? It's like, we've done it this way. Now let's look at how we can maybe do it a little bit. We'll call it better. We don't want to say it's better than the way they did it, but it's like a little more efficiently, a little bit faster, a little bit more maybe cleverly, as Kathy Fosno would say, right?
Yeah, and that's a great point, Kyle. And I think another I'll bring up a kind of a pushback many teachers might be saying right now, and saying like, well, how do I do that with the time I have? And like I can teach them up front, and then we're over, we've given up, and then by the end of class, they're pretty much fluent with the skill we're trying to bring about. Except that like you gave kids the shortcut, right? Like you started with the shortcut to that lesson. Like that's what most of the math we teach in high school and in middle school is. Really, the math itself is a shortcut to solving problems. It's all a series of different shortcuts. Like we have so many shortcuts in our daily life. Like when you drive your car to work, that's a shortcut that someone created the automobile so that you could save time. That's a shortcut. So many things that we have are really shortcuts to doing other things. Like this podcast, Kyle, is a shortcut to teaching math better, right? Like I listen to the podcast because I want to get ideas, and that's a shortcut to help speed that up for you. Math class is different shortcuts, and I think we rob kids from attaching value to learning by just handing them shortcuts without having them experience why the shortcut is needed. And I think you talked about that in the sense of like we've got to put kids in these situations so that maybe we want to bring this efficient strategy to the forefront, and we got to feel that, right? Like kids got to feel why that's needed. And if you just hand them a shortcut, they don't feel that. And if they don't feel that, they don't attach any value to any of the learning they're doing. That's why kids say like, why do I got to learn this? Right. It's because there's no value there. You've given them a shortcut that they didn't really care about anyway. So we got to put them in a place to feel that. And I think that part is worth the time for me. And I brought up this idea that we don't have time to say, put them in these situations where they are going to struggle through these problems. And then you're still going to help them with a shortcut later on. But that struggle and that value attaching to their learning is worth that time in my end. Like I think they will remember the content, like they retain the ideas and the shortcuts or the mathematics that you're going to discuss in that lesson longer and stronger because they experienced that struggle or that need to have something better than where we are right now.
I love it. So let's dive in, because like you're talking about, want something that resonates with them. You want to give them this opportunity to problem solve and to essentially like use their brain, right? Like actually think in math class. And, like who would have thought? I taught for so many years where, I don't know how much they were actually thinking during the class, maybe when they were doing the practice problems, they were thinking, but it was like, I did like all of that heavy lifting. So, let's talk about a couple examples. I'll talk about one, and this is one I used recently, so it's kind of fresh in my mind, but when exploring, here's this concept. So to kind of, take you down the path of what we've been suggesting here is like, okay, we need to understand like, what's the intentionality of the lesson? Well, for this lesson, we wanted students to be able to come up with an equation of a line when they're given the slope of the line, so the rate of change, and a point on the line. Okay. And the way I used to teach this concept was a naked problem. And here's the thing. I used to select the values to be very, very like easy numbers to work with. Cause I thought like, if the numbers are easy, this will be so obvious and everything will be fine. The calculating is not going to be distracting. Like nothing's going to get in the way. But the problem was there was really kind of no context, and the students were like, well, I don't know what's happening here. So, I'd model that for them. I'm like, here's the slope. They already know what the slope is because we've done lessons on slope where I told you what slope was, right? This is before my time of problem-based lessons. And now I start to realize, and I go, okay, well, what could I do? And, you flip to that textbook and you kind of look at some of those word problems and you think like, are there any scenarios here that are like realistic, or maybe you can come up with one yourself? And for me, I just thought about packs of paper sitting on a desk. And, it was like the relationship was how many packs of paper and what's the total height of the packs of paper while they're on this table or on this desk. And, for those who may not be kind of in those middle grades where you're playing in this land, just to, kind of give you a heads up, basically what we're looking at is like the equation would be whatever the height of the table is. That's like what we call the initial value plus the height of the stack of papers. And basically that would give you your relationship. So, you could say it, or you could just have like a visual, like you could have a visual of like 5 reams of paper on this desk. And, you tell them the total height and you tell them how many packs of paper, but you don't tell them how tall the desk is. And right there, I don't have to say anything. I don't put a title on the board. I don't do anything. I just ask them like, I wonder how tall this table is. And, before I even give them measurements, we could just have them estimate, like just you're looking at it. You've seen a ream of paper before. It's like, I don't know exactly how thick they are, but I can make a guess. Students can make a guess. I don't know, 30 centimeters, 50 centimeters, whatever their guess is. And then they could use their spatial reasoning to kind of scale that and go, I don't know, it's maybe 150 centimeters, right? Get them all estimating. And then after I could reveal the total height, and I can reveal the height of one package of paper. And then I ask them to update their estimate. And for those who are sitting there, I know, many people are listening, or, some people are watching on YouTube, but if you're listening, like if I know the height of each pack of paper, I could very quickly figure out the height of the 5 packs of paper. And if I know the height of the entire packs of paper and the table, all I need to do is subtract those 2 values, and I've found the height of the table, which is the initial value for this relationship. And what we've just done is we've used, without kids realizing it, and for many years I didn't realize it, that basically that process is how you would intuitively use like your reasoning skills in order to battle your way through that problem. And then once they share that out, it's now my turn to kind of do the beginning of the lesson, my old beginning of the lesson, where I go, all right, here's this thing. Remember slope from the other day? Bam, there it is. Here's this. Bam, there it is. And then I can serve up that next example and I could give that to them. And instead of, again, me doing the example, I could say, I want you to try this one. I think you can do this one. And kids are going to be like, they're ramped and are amped and ready to go because they just saw that they solved a problem without me telling them anything. And now I've just made some sense. We just named some things like, what you did here, like what John just did is this. And what this student over here, you use a really cool strategy. That what you did is called that. And then all of a sudden now we go, here's this other problem. I'm wondering, is it going to work the same way or is it going to be different? How do you know? Are you going to be able to convince someone? Get to it and then share with a neighbor. And next thing you know, it's like less of me and more of them. And that's exactly what we want when we see, students thinking in a math classroom.
Yeah. And I think what's really important to point out here, Kyle, is that your kids are doing the thinking, and then you are doing the summarizing at the end and naming the things that you want to name, and then making that say consolidation or the note right at the end of the lesson. That usually, this is where this flipped idea comes from, is that you did problem 8 from the textbook first, and then you unpacked it. And then you've done problem, examples 1, 2, and 3 afterwards. And again, at that point, if kids are already showing that they can do that, they can then do problems 1, 2, and 3 on their own. And then you really probably didn't have to do any examples in front of them. And I think that's what happens. That's what happened to me as we did that process. It's like, well, we did a hard problem. We put them in a position that they could solve using inefficient strategies. We tied it together so that we talked about efficient strategy. Now it's like, okay, well, now do this one because you did this one, but we've talked about an efficient strategy. It's almost like I used to do like 4 examples before before setting them to do the homework or the practice questions. And then you're trying to cover your basis to get all the pieces in there. But then if you pick your problems right at the beginning of the lesson and have them do it, you don't have to do anything. and they do all the thinking, and you're doing the guiding, you're the guiding after that. So another example I'll toss in here quick that I referenced earlier about like terms, and I think really a big idea, like what you, in order to pick the problem, right, Kyle? Like picking the problem is important because it has to be open enough for them to try different strategies without, say, knowing the goal or already understanding and knowing the goal that you're going towards. Because maybe they can't solve it without that. It's like you got to pick that problem that like allows them to bring in those like inefficient strategies, so that you can talk about it. And like, for example, if I'm talking about like terms, understanding the big idea behind these topics is so important because it will help you pick that problem that allows it, right? Like if you're like, well, like terms are about just like adding X's together and collecting those like terms and adding these. Like if that's my understanding of why like terms are important in mathematics, or the big idea of what we're really doing there, then it's going to be tough to pick that problem because I only see like terms that way. And when you see like terms as creating equivalent expressions or looking at like what grouping items together to shorten up the calculations, right? Like if that's an important aspect. It's like I could put these you can hear my cat.
I'm here. Just smirking because
we'll keep it in.
Yeah.
It's taboo. He's going crazy. This is the one you took a picture of on the weekend
for the virtual summit. Just passed out on the couch. Totally mathed out.
So back to the idea of the big idea is like that you have to know what that is. And so like in like terms here, if I can group things together, I can shorten up calculations and create equivalent expressions that are nicer to work with. Those are big important ideas, like the equivalence. That's really a huge idea there. And one thing you could do is, right, like one thing that's easy to do is, instead of just saying let's add these like terms together, I've seen it done lots of different ways, but you could throw up this shirt costs this and this shirt costs that, or this, these pants cost this, and then it's just throw them all up on the board and then say total it all up. And naturally, kids are going to do a strategy that they already make sense to do, is group all the things that speed that calculation up. The last couple of years, I've created a big page that has a ton of different shapes all over it. Rectangle, and it's building on our work that from area of rectangles and squares, and trapezoids, like this shapes. But there's a whole bunch of the same types. So there's like a whole bunch of triangles that are exactly the same size. There's a whole bunch of squares that are exactly the same size. And I just say, find the area of all these things. And I pretend that I've got to do something else. So like, hey, guys, I need you guys to do this problem while I get ready for the real problem, which is a lie, right? Like that's the real problem. And so I'm pretending to fiddle with stuff at my computer. And students are like, okay, well, I guess, all right, so we're going to do the area of this. And then it's like, so then we take this up, and they've all grouped all these ideas, all these same shapes together, and found the area of one, and then said, well, there's 7 of them, so we're going to multiply by 7. And so then we then take that work and we're like, well, let's write a formula because, oh, wait, I forgot. Sorry, guys. I got the dimensions wrong. And then I changed the slide, and it's the same shape, same orientation, but all the dimensions are changed. So then it's like, they're like, oh, they got to do this again. And so they're like, do this again. And then some kids are like, I don't think we have to do that really again. We just have to change a couple numbers here. So we're like building an equivalent expression for the area of all these shapes. And we're understanding there's power in grouping, and there's power in simplifying, and in creating this equivalent. So like, if you can understand the big idea behind the math that we're trying to teach, and you got to go big, right? You can't just go like granular. Think, where does this fit? What's important about it? How does it fit in the grand scheme of things? That can help you immensely in choosing what is the problem to start with.
I love it. And something that I think you touched on a little bit, so I won't go too deeply in it, is, a pushback we often get, or just a question, like a common question you get is like, what if I can't think of a good initial problem or the reason for this concept to be taught. Like some people are like, I don't know, like we always push for context wherever possible, but really context is only important if it helps you with the thinking. So it's like, we don't want contrived context. Like the one with the area that you just described, it's like, there wasn't really like context. The context is the fact that there were visuals and there was, area. So the context is, we know what area is. Like they have an understanding of that, and they can kind of like build off of that.
Right.
But in reality, it's like what you've done. Yeah, it's super low floor, and you've created almost like a bit of a puzzling prompt. Like your puzzling prompt was almost a non-prompt. You basically said, hey, just like stay busy for a couple minutes, and that was your way to kind of get them into entering into that problem. And that's like using some of the elements of that curiosity path, which we don't want to like mar down today's podcast on making the prompts curious, because that's something I think you can work towards over time. Withholding information is always helpful. So like John, you had kind of withheld information in that particular scenario. I withheld information with the stacking paper problem by not having measurements on the image at first, and had them estimate. So we could do all of those things. But the reality is that as long as it's puzzling enough or challenging enough, or, again, those are two things that help to make it curious enough for students to enter into a problem. The example I love is, you were describing it a little bit earlier today, is this idea of finding the distance between 2 points. It's like we could just start by just having like 2 points on the screen and nothing else, and ask them like, how are you going to measure like how far they are, and like there's no context there. Sure, you could say, hey, this is this town and this is that town. Like you can add that if you'd like, but we're trying to give you a scenario where it's sort of like, because it's such an easy entry point, it's like almost irresistible not to participate, because you could have kids estimating, like some kids will like think standard measure, and they'll be like, that's like a foot apart, and we're like, oh, okay, that's a foot apart. Like, yeah, what if we didn't have a measuring tool, right? And then all of a sudden maybe we throw a grid on there, and the grid has like a scale on it. It's like, oh, those are actually kilometers. Okay, great. Now how far do you think? And that, getting closer and closer to build the need for a means for us to actually get a more precise calculation, or a more precise quantity that we're trying to unveil through that problem. So that's another big one. So again, don't like put too much pressure on yourself for every single initial prompt in your class to always be a grand slam, because also, like, think about it. We're telling you to keep your lesson that you were going to use, and use an element of it in a different spot. So, I mean, really, that's what your lesson was going to be anyway, right? So don't overwhelm yourself and maybe not do this process because you're worried too much about making that intro problem perfect. Let's just get that order swapped and get comfortable making that the routine in your math class, where like when we do math, we start with math and then we make sense of what we've done afterwards. And that's kind of, I think, the big sort of takeaway we're hoping people are hearing out of this episode here today.
Good summary there, Kyle. I think you've really nailed one of the big ideas we want to drive home here in this episode. I think before we wrap things up here, there's a couple things we should bring back up too, about like what happens if this happens. When you're trying something new, you start to think about what happens if this is going to happen. And then we've got some common things that have happened to us, like what happens if I change this, but students aren't, say, engaging in that initial problem, right? Or that initial task. And, I think one thing we can do is kind of like, if that's true, like if you set the bar low floor, and you brought that task in that built on maybe what they did the day before, or maybe it was like my example with the area. We had used area before, but we were really kind of like putting it in a different context. If that's not getting kids to like step into the problem and get thinking, and that's probably going to be like that the first time you try this. They're going to be like, wait, you usually show us what to do if that's the case. I'm still going to wait here for you to show me what to do. Well, that happens to us a lot, especially when you start a new class, the new year, and you ask kids to do this. They'll kind of like held back. I know something that has worked well for me, Kyle, is you've referenced the curiosity path and how to adjust for that. I think, and we're not gonna go down that path, but that can work. But the other thing that has helped me so much in the last few years is getting our students standing and getting our students to discuss with each other, and me putting the whiteboards up on the walls has changed so much about how much engagement initially happens when I pose that problem. I'll say, let's go to the walls, and students are right away working at the walls to solve that problem. I think just the fact that they're standing has changed that part. So that's something that folks might want to give a shot to. It's one of the easiest things you can do and not change anything, not change too much about what's happening on your day-to-day planning by having them move to a wall space to work in partners.
I love it. I love it. And, the other thing that came to mind, as you mentioned, that is something that we used to do. And again, you might feel comfortable doing this, and maybe this is your comfort zone, but, I would encourage that if you do want them truly problem solving, try to give them, as little as possible up front. And that includes like a handout. Like I used to always,
right.
it was almost like, I wanted to make everything so easy for everyone. Like I thought that was what they needed. So I'd have a template, and there'd be, a graph and a table, and like, fill this in and fill that in. But that template sort of approach, especially with this upfront problem, I'm not saying you can never give a handout during your lesson. Like maybe at the end of this problem solving, you might have a summary that you want to work, and build something together just for, time efficiency and things like that. We're not saying to never do that. But what we are saying is that if you want them to truly come at this problem with their own ideas, their own strategies, their own tools and models, you don't want to, give them a paper that has a table on it and a graph on it, because then in their mind, they're going like, Mr. Pierce wants me to do a graph, right? And maybe that wasn't where their brain was going. And maybe the point of the lesson is to graph. But remember, this intro prompt, this intro problem isn't for them to show how awesome graphing is. We're trying to almost like do the opposite, like show them how helpful graphing can be afterwards. Some students might choose to do a graph, and that's super cool, and you'll get to highlight that. But when we sort of like send them down this path, it's like you're sort of like you're making them stop thinking a little bit, because they see what's on this template, and whatever they had in mind, they're like, oh, well, that doesn't fit on here, so it must not be good, or it must not be valid.
Yeah.
So just an idea to maybe, I wish that I would have known that ahead of time. It would have saved a lot of, I guess, trouble with trying to get my students to start thinking,
Yeah, good point there, Kyle. And I know that I still use templates, but like you said, I introduce them after the fact, after they've tried their thinking. Two examples come to mind in the same topic. One is when we've done your task on the candle burning task, and getting kids to, the candle burning task is you can see this candle burning, and then you're trying to figure out how long does it take to burn completely out. And for us, we've used that as an introduction to scatter plots and using lines of best fit to model things, to model the data. And in the past, if I gave them the template first, like you suggested, Kyle, there's no thinking. We just fill in the table, we fill in the graph. He's like, now you still have to go, this is a line of best fit. But when I changed that lesson to not give them anything and ask them to answer, kids are actually most kids actually won't use a graph in the beginning. They will take the data points and they start to average them, and then they start usually kids will start to build a linear equation actually out of it, and start to go, okay, well, if I average these and it's going down by this much every minute, then how many minutes until it runs out, like, which is amazing because it's like there's so much to unpack there. And then then when you bring in on your consolidation, if you still want, you're going to introduce lines of best fit. What a perfect way to talk about what a line of best fit. Hey, it's an average line. What did you guys do? You made the average. What did average did you get? Oh, it's this nut. What is our slope of our line? Oh, it's all about the same. Like you can draw a line and you can say, look, at the power of the graphical solution here is that you can visually see where this is going to end up, and it's not so, you're not so bogged down in some of the algebra that you guys were in it. But if the kids were doing the algebra, hey, that's awesome too. And then we have also used that when we did Barbie Bungee activity for the exact same skill, in doing that again. So important to bring up these ideas. Kyle, I think let's do a quick recap here, folks. We wanted this big idea to come out being like that. Something you can do tomorrow is take your lesson and just reverse parts of it, change a couple elements, put one element you might have done later at the front, get our kids to think. That's an important aspect, because creating that thinking will do lots of side benefits here for you, with getting them to see the shortcut, which is a lot of power, and also getting them to attach value to learning. And you students are going to deepen that understanding deeper, because they've made actual personal connections to that. And think about this, Kyle. This is also, we didn't talk about this in this episode specifically, but when you get your kids to think, you are telling them they're worth the time to allow, to have that thinking happen in class. Like there's value in your thinking, and I want to see it. Like, think of the message your students get when you dedicate time at the beginning to go, I want to see what you're going to come up with. I want to see your thinking here. And kids are like they'll feel empowered and they'll feel worth it.
Absolutely. And, you just kind of gave me, another epiphany here is, sometimes educators, we tend to tell students not to do things certain ways because we want them to get to the thing we want to, them to be using, like the graph. And, in your lesson, you could have said, oh, don't average them all. Don't average all those data points. Like, I want you to use the graph today. Right. And there's a time and a place for that. Like, so in some of the practice problems, you can specifically ask them to utilize a graph in this scenario. But again, in that upfront learning part, valuing their voice, valuing their thinking is so key. And, the one big takeaway I hope you walk away with is, again, this idea of getting in the habit of how you start your lesson. Now, mind you, I'm talking about a problem-based lesson. There, some people might do like a number talk or a math talk before, but I'm talking about when you introduce this new concept that you normally do your note on the board for. We want to just get you in the habit of getting students thinking first. That will give you so much space, and it will give you so much more attention, because students have already grappled with the problem, and then bringing it together is so much easier for you. So it doesn't feel like you're talking and students are kind of looking at you like you have two heads, right? Like, they were all a part of the process. And now we can use that thinking in order to drive home the big idea, the big point at the end. Another key piece that I wish I knew was, when you do a problem-based lesson, we don't just do the problem and then just hope everybody got it. Right. I did that a lot. And that's where I think we get a bad rap when we talk about problem-based learning or inquiry-based learning or discovery-based learning. It's like this thought that, students will just kind of like they'll do it however they choose to do it. And that's just it. And that's the way it goes. And it's like, no, we have to be really clear to bring it together and bring that new learning to the forefront. So you're still getting that opportunity. You're not throwing out all of that good stuff that you would normally share with students. We're just going to do it a little bit later in that lesson, and then give students other opportunities, other prompts or problems to work on to kind of drive home that point. So wow, this one's been a big one, as they all are there, John. I don't know about you, but I love talking about how we can slowly transform these lessons. And I'm hoping that everyone feels like this is something that they can actually do, that you can actually attempt to do in tomorrow's class. And I don't know about you, I want to hear from some friends, whether you're responding on the podcast episode show notes page, or whether it's under the YouTube video on YouTube. Would love to hear how this went for you. And remember, it might not be perfect the first time, but get in that habit. Try not to break that streak, because if you do this once in a while, only on Fridays, you're not going to get that consistency from students knowing that this is how we learn mathematics in this classroom. So build that routine. Your students will follow, and you're going to, I think at the end of this, you're going to feel like, wow, you're seeing a ton of thinking that you never realized was there.
Yeah, exactly. Thanks, Kyle, for that. And as a reminder, please, do what Kyle said. Share your big takeaways with us. That might be on our Twitter page or Instagram, or in our free private Facebook group, Mathmo Makers K-12 over on Facebook. Share what you've been learning. Share all of the things that you thought. Maybe you disagree with us. Share that too. We want to hear from you. And then don't miss our next episode. We're putting out episodes every Monday morning. And to be sure you get that next episode, subscribe. Hit the subscribe button right now if you have not yet done this. Maybe this is the first time you've listened to us. You can head to the back catalog and get all the episodes that we've ever had in the last 3 years. So subscribe. Kyle, we're coming up on our anniversary of how many? It's 3 years, right? Coming up, I think.
This is crazy.
Wow.
Holy smokes.
Yeah. So subscribe.
This has been fantastic. I'm just looking at the episode number even there, John, and it's like, I think it would have been last week's episode that went out. That would be like the official, even though we've talked about we jammed a couple extra episodes in at the beginning. But holy smokes, 3 awesome years. Friends, go check out those show notes and links to resources on our wonderful, wonderful show notes pages on makemathmoments.com/episode 156 for this particular episode. Or is it 157, John?
Yes, 157, Kyle. Thanks for correcting that.
There it is.
This is episode 157.
Yeah, there it is. Okay. makemathmoments.com/episode 157 is where you can find transcripts. You can find links to resources, all the show notes. And, obviously you've got the gateway to all kinds of other ideas like our problem-based math lessons. Once you're there, click on the tasks and you know what? Let us do some of that hard, heavy thinking for you by using some of those problem-based units. All right, my friends. Well, until next time, I'm Kyle Pierce.
And I'm John Orr.
High fives for us.
And a high five for you.